Okay, let's get started. So first we'll create a player, and so we'll just use a capsule for this. And of course we'll call it player. We'll also like put it at the right position, just so we can see it a bit better. So one up and a bit to the right, that should be fine. Then we'll also create an enemy. We'll just use a cube for now. I will call this enemy. And so we'll also reset the position and move it a bit, so it's easier to see. Okay, here we go. Yep. Okay, and so now we're going to tag the enemy and the player as their appropriate tags for ease of use later. Um, so now that that's done, we're going to create an enemy script. And so this script will dictate the behavior of the enemy. So when it will attack, where it will move, and all that sort of stuff. All right, but first I'm going to explain it a little bit. So the script will work like this. We have the enemy, and then we have the target, or the player in this case. And so what we do first is scan around the player to see if there's anything nearby we can lock onto, sort of, so to speak. And if there is, great, we'll just go to this. So we'll shoot a raycast in the direction of the target, and we'll see if it's possible. But so we need to shoot a raycast, because if there's a player, for example, behind the wall, we won't be able to reach them, so we need to try again. All right, let's get into it. So first we'll create a couple variables. So there will be a public float max speed, so to dictate the maximum speed. Then we'll have a private float, actually, a private float of just speed. This is just to keep track of our current speed, you know, if there's like effects on it, like slowdown. Then we'll also have ourselves a collider list for the hit colliders. We'll use this later for the sphere checking, right? So to see if there's anybody in range. And then also a raycast hit, and that's for like the raycast, the laser, to see if it's in the line of sight. Then we'll have a couple more variables. We have two ranges. So one is for the sight range, so like vision range, and then the other one is for detection range, so the circle range. So the one is for the raycast, and the detection range is for the circle range. All right. Then we'll also have ourselves just one more variable, I think. Yep. So the a rigid body. Oh, and also we can't forget like the player or the target, because we'll need to access that later. And that's, oh no, actually there's one more. We need to have the see player variable to check if we are currently seeing a player, or we're currently looking at one. Okay, so what we need to do first is detect if there's a player in range. So how we do that is, as I said already, we make a sphere cast. So we check in a sphere. So if there's nobody who we can see right now, we're just going to check in a sphere. So we do that by writing hit colliders equals physics dot overlap sphere. And then as our parameters, we will giving our current position, so the center, and then the radius, just how a sphere is calculated. Okay, so that's all we need for now, and we'll put in the detect range as our radius. And then we're gonna loop through each collider we hit. All right, so for each hit collider in hit colliders, we're gonna check the tag of the collider. So we'll do that now. So we're gonna check the tag of the collider and see if it's equal to player. Because if that's the case, we know we've hit a player and we're gonna want to proceed. So let's do that now. So tag equals, and we use double equals because remember, it's an if statement. So we check if we want to assign a value, it's just a single equal sign. All right, so now we're gonna set our target equal to the right collider, so to the player. All right, so now we set our player as the target, and we're also gonna set see player to true because we're seeing a player. So now if you see a player, so if somebody's in our range, we're gonna check, we're gonna do a raycast from our position to theirs, and we're gonna do that using, so first we need our origin, so that's where we are, transform.position, and then to calculate the direction, we just have to do the target direction, so where you want to go, minus, or the target position minus our position. And if you use vector math, that's how it goes. So we use the player position minus our current position, and so that's how we calculate the direction. Then we have an out, so what it will return. is our hit. We already defined that variable, and our range of the ray is going to be sight range, which we already also defined. So now we're going to check if the thing we hit is actually a player and not a wall or something. So we do that real quick. Yep. And so you gotta keep in mind the word player has got to be spelled right. It's got to be exactly like the tag. And so if this is not the case, then we say see player is false because we can't see the player anymore. But if it is, if it is the case, excuse me, then we're gonna proceed and move our enemy towards the player. So that's what we're gonna do now. Now, to do this, first we'll just start off by making a new vector tree. We'll just call it move or something. So move equals new vector tree, and we'll just default the values to 0 for now, but we'll change this later. Okay, and then we'll say that the rigid body dot velocity, so rb dot velocity, yep, equals move. So now we will move in the direction of this move vector. Now, alright, so now we're going to calculate in which direction the player is, but we can't use the same method as the one we used in the raycast, because that scales based on distance. So the vector is the same, but the size of the vector is different, right? So if the player is farther away, it will, the speed will get messed up later. So we need to normalize this value. And so this is the way I do it. There's other ways to do it. So again, the first step is the same, just target position minus current position. And then what we do is we take the magnitude of that vector, right? So the size of it, so how big it is basically. You can just imagine this as an arrow and just see how big the arrow is. And then for the direction, we just divide our heading by distance. And just that's how we get our direction. And then of course, to move to that location, that direction, we need to multiply our direction by our speed in the move variable. But we only want to move on the x and the z plane, not up and down, because if you raycast, so the center of the player is a little higher usually than where the enemy is. So, and if you just do direction times speed for that vector tree, you will the enemy will start floating above the ground, and that's not what we want. So we'll just do this for now. You can change it if you want, but that's how I'm going to do it. And actually, for safety purposes, so that we're always targeting the same thing, we're going to do target position instead of just transform. And we'll also set the forward vector of our enemy to the same vector as our move. So our forward direction is also always facing the player. And also set the speed here to max speed in the beginning, just to start it off. Okay, so now we're going to add a rigid body and drag it onto the RB variable, and we'll set some values for our speed, our sight range, and our direction, our detection range. And now if we play, you can see the player is, so now as you can see, the enemy is moving towards the player, just as we intended, and we can drag the player around and we'll just keep following us. But it doesn't do any damage yet, so we're gonna fix that now. So to do damage, we also need to be able to take damage, right? So we're going to add a health script on our player for now, or this is our player. And we're going to have two variables in the beginning. So that's our max health, excuse me. So our max health, we'll define that now. And then we have our actual health, so our current health. And that's a private, and those are both floats. A float is a decimal number, by the way, so like a number with X amount of decimals. So first we set, at the start of the game, we set our health equal to our max health, and actually I'm going to rename this to current health because that's a little easier. And then we're going to make a new function, a public function, and we're going to call it take damage. So public void take damage, and we're going to have one parameter, which is a float. We'll call it amount. So in that parameter will be like the amount of damage we take. So we're going to change our current health by amount. So every time this function is called, we're taking damage by a certain amount. And then if our current health is below 0 or equal to, then we'll just say that we died. So we can log this in the console. Just right there. So the player died. Yeah, okay, no, yep, the player died, and we can also just reset the max health, the health to the max health. So normally you can respawn here, but we're not gonna do any respawning today. We're just gonna reset the health to 100 or to like the max. Now in the other script, now we can actually do damage. So we need a couple of more variables. It's one is gonna be damage, one is gonna be KO time. I'll explain that later, and the other one is gonna be can attack. So that's a boolean. So two floats, damage, KO time, and a boolean can attack. So now we're gonna check for collisions. So if our enemy collides with something, we're first gonna check what have we collided with. Okay. So we're gonna check the tag of the collider, so the thing we collided with, and if it's equal to player, then great, we can do damage. If it's a wall, we don't do anything. So now we're just gonna look at the game object of the collider and get a component, and we'll get the health component, so that's the script, the health script, and we're gonna trigger the take damage function. And now remember, we could pass a float in there, and as that float, we're gonna say damage. And actually, just to demonstrate, we're gonna make it a serializable field. That's just so we can see the expector on the right side. We'll now set a damage. Oh yeah, we forgot to save, so let's save that real quick. And so now, if we test it out, all right, you can see on the bottom right, we're taking damage. We're taking 20 damage every time we get hit. But there's a slight problem. Our enemy doesn't stop when it hits you, so it will just keep chasing you no matter what. So we want to fix that. So what we want a small delay between attacks, right? So if it lands an attack, we want it to stop. So we'll add a new IR ruminator, and basically this is a kind of, we can use this as a delay function. So every time we call this function, we pass in the delay. And so to write this function, we write yield return new wait for seconds, and then as the seconds we pass in our delay. And so after that happened, we set our attack, so can attack equals to true. I mean, yeah, true. And then our before that happens, we set our can attack equals to false. So first it's going to be false, then we wait for an amount of time, and then after time we say that's true. And also before we actually can do the damage, we also need to check if we can attack. Okay, and now we're gonna call that function. So you do this by typing start coroutine and then attack damage or attack delay, and then as the delay we'll pass in our KO time, which we said earlier, and this is basically the time the enemy will be knocked out after an attack. We'll also make sure that the enemy can't move during that period of time. So we'll set its speed to 0, and after it's done, we'll set its speed back to the max. Okay, perfect. And that should be almost it. Oh yeah, also it's just IR numerator, not public, and also set the attack variable to true, so it can attack. And now if we check and we set a KO time of like 3, for example, it goes to our player, and just after 3 seconds it can start moving again. You can make this shorter, and like in this time you can make like an animation, maybe a charge animation, like you have a rhino or something and it charges at the player and then it just staggers for a bit. Now one thing to notice is if you have 2 enemies, only one will actually lock onto the player, and this is because the other player enemy is blocking the line of sight for the player. So move them both to the raycast ignore layer, so the raycasts will go through enemies, and so that's really helpful. But guys, this is about it for today. I hope you learned something new. If you did, like, subscribe, and leave a comment down below, and I'll see you guys next time. Goodbye.